All right, so for day one, for addressing the climb or the hangers, the goals the zookeepers set out to do is to address first the mid-rung and then try to go for the high rung. The traversal rung, it'll be cool if we can get it, but we're not necessarily set on getting it. So we're first going for the mid-rung, which is one that we can fully extend to from the ground. So this is the overall design we're going to use. We're going to have a cascading elevator, or not a cascading elevator, it's only one stage. So we're going to have chain going around this sprocket. It'll be driven, this isn't a complete CAD model, but it'll be driven by a gearbox down here with chain going all the way up around this sprocket, and then it'll secure itself to the next stage in between here and then continue back down to this sprocket. Now, in order to be able to traverse to the next rung, what our plan is to use is like these secondary passive hooks. So the way this will work in theory will be these arms will extend up, they will grab onto the rung, we will pull the robot up, and then once these come back down, I believe the lowest point they go to is right about here. These will engage, and these will be driven by a motor down here that will be geared very high. I'll talk about that in a bit. But essentially, now that we have these locked on, well, they're not locked onto the bar, but they're close to. They're right above these. These will start inching up and essentially pass off the bar to these hooks. And so once these are disengaged from that first mid-rung that we're going for, what we can do is we can shift these arms this way. So essentially the way our robot will look approximately will be something like this. These will need to go approximately 63 degrees, if not more, which is quite a lot, and we're going to have to counterweight the robot in theory. So then this extends to the next rung, and this will then shift our robot back as we need it to for these to engage the next rung. And then once these are engaged, we will pull ourselves up a little, disengage these, and repeat the process. So in theory, you'd be able to continue to climb to the next one, but obviously we'll need to test if this even works. So in terms of gearing everything, what we used was the Jvn Calculator. So if you're not familiar with that, you can just search Jvn Calculator Chief Delphi. It's already popping up for me because I've searched it. And you can, I don't know why I'm zoomed in so much, but you can download one of these Excel files, open it up, and it's very useful for calculating what gear ratios you need. So for our passive hook, which is going to be just hooking on, what we did for this was we decided we would use two 775 Pros, and the arm length is essentially the distance between our axle right here and our center of gravity. We don't yet know what our center of gravity is, but we are assuming we're going to try and get it as close to the elevator as possible, and we assume that it will be no less than a foot away from this axle. And so that will be our moment arm, or like the distance that the force is acting on the robot. And so the center of gravity, we take it to be somewhere around here. We're making a lot of assumptions here. And our robot weight, we put at 155. And so from there, we're going to be using a 100-to-1 Andy Mark gearbox, and then I believe they're called Bainbot dual inputs, that you can find them on AndyMark, and those have a gear ratio of 3.25 to 1, and so that's how we're coupling the 2775 Pros to the 100 to 1 gearbox. And then the sprockets you saw on this CAD model, I don't have one on this side yet, but we'll have a 22 tooth to a 40 tooth sprocket. So that'll gear us down for a total ratio of 590 to 1, or 591 to 1. And so from there, we found that our max stall load is going to be 402 pounds, which should give us pretty good clearance. And this is assuming only 65% efficiency in the gearbox. Now for the elevator, you can also use this calculator. We're going to use a single 775 Pro with a 48 to 1 AndyMark gearbox, which was sponsored to us by AndyMark this year. And then we will drive it with a sprocket, which will add 40 to 22. So this is the 22 tooth sprocket, 40 tooth sprocket up here. And that will give us a stall load of 466. And also the arm length, we have it at 12 inches. In theory, we think ideally it's going to be closer to 6 inches, and so that would double our max stall load. And just to show you guys the extension of this, we're actually already folded up, so I'll show you guys what that looks like in the CAD model. Let me make sure we're not too low, that we're hitting this. We'll put a hard stop there later on. Gonna go ahead and save that. Open up my drawing file. All right, so starting configuration, 43.7 inches. The -1 is because we actually switched out our wheels to be 4-inch wheels instead of 6-inch wheels. So we're an inch below that, so we'd be 42.7. So we're well below the total height thing. Well, I guess this top one will be folded forward during our starting configuration. Now, the bottom hook would be 37.52, which doesn't really matter in this configuration, but then whenever we extend this up to our full height, let's see where we're at. So again, that puts us at 66.69 minus 1, so 65.69, which is within the 66-inch maximum height that you're allowed whenever you're climbing. And then the hook is at 60.51, the bottom of the hook, which will allow us to grab onto the bar, which I believe the top of it is at 60.25. Yeah. So in theory, this should work. In terms of staying within the frame perimeter, let's go back to the assembly. So we don't plan on going too far this way, but we're obviously going to go very far forward in order to go to the next rung. And whenever we do that, even if we actually fold all the way out, it's still within the 16-inch perimeter rule. The only other thing here to note is that we don't actually have 3 motors on here. We have 2. This is just the CAD model, so it won't interfere with that. But tomorrow we plan on starting to construct this, and hopefully we will have more of an update and maybe be able to test it for once tomorrow or Monday.